A group of high school students have been observing today's solar eclipse, and Dave is out there now to talk to a few of them. Dave?
Studio now, because people are making strange signs at me. Lois?
Okay, Dave, and things have certainly changed over the years. We now approach, as you can see, the eclipse as a scientific phenomenon. Thousands of years ago, though, it wasn't that way, and we are joined now by Dr. Melvin Kranzberg of Georgia Tech, who is going to tell us how they did look at an eclipse in primitive times. Dr. Kranzberg?
Well, as far as we know, Lois, they didn't have written records, so this is mostly by legend. But we do know that they were scared witless when this happened, because here is the sun, the giver of life and heat, and suddenly it is being obscured. What was wrong? What was happening? And they viewed the sun and the stars and the planets as being godlike creatures. The sun god, you see, for example, the Egyptian pharaoh was the son of the sun god. There was a goddess of the moon and so forth. Or they viewed the heavenly bodies as being driven across the sky by gods in chariots, you see. They had all these explanations trying to figure out what the stars and the moon and the sun were. And when the sun was eclipsed by the moon, they didn't realize that what was happening. They thought that something had gone wrong, that they had perhaps sinned, that the king had not been doing things properly, and everything was fouled up, and they were scared to death. Now, they have different myths in different places in the world. In China, for example, they thought a dragon was trying to eat the sun. And the thing to do was for everybody to go out in the streets, make as much noise as possible, bang pots and pans and gongs and so forth, in order to frighten the dragon away.
You mean the dragon is not eating the sun? No.
Well, you can't prove that he isn't, of course.
I'm just talking to Dr. Bice, probably a friend of yours, and he was mentioning to me that there are incidents during past eclipses where people were psychologically disturbed, I guess.
Oh, yes, and they did all sorts of strange and queer things, just as, like the legend of the werewolf and the full moon. And so when you have an eclipse of the sun, which counts for so much in human history and, of course, in the environment, why, when that happens, why, people become very, very frightened.
Okay, and moving along to the early Greeks, now they were fairly enlightened. They had some of this figured out.
Well, the interesting thing is that the Assyrians and the Mesopotamians were able to take observations of and predict eclipses before they actually knew what was happening or what caused them. The Chinese were able to do that. The Mayans in Central America, in South America, were able to do this. But we don't quite know how they interpreted that, because we can't read their writing. But we do know that they could forecast eclipses and so forth. So could the Assyrians, so could the Chinese, but long before they figured out an interpretation. Then when the Greeks, for example, figured out, Thales said, well, the moon is shining by the reflected light of the sun. And he had some very scientific ideas, but these just didn't jive with their mythology. And so you had this mythology, in a sense, given by Claudius Ptolemy in the 1st century AD. He wrote a book, the Almagest, which described the motions of the sun, the moon, and the stars in relation to the earth. And he said it was a geocentric world. And that idea of the geocentric world, that is the Earth at the center of the universe with the sun and the moon going around it instead of our going around the sun and the moon going around us, stayed until Copernicus came in the 17th century and overthrew the whole notion of the geocentric world, said that we live in a heliocentric universe. Now, of course, we realize that we are part of a sort of a third-rate planetary system in a second-rate galaxy, you see.
I imagine there are some cultures, though, who still attach a lot of mythology and superstition to it.
That's right. Well, we still have astrology.
That's true.
And astrology,
in our newspaper every day.
That is right. And, our original astronomy was based on astrology. People were trying to figure out what caused the sun, the moon, and the stars and the planets to behave as they did. They were seeking for answers.
Okay.
Dr. Kranzberg, always delightful to have you with us. Thanks for joining us this morning.
Ben, look, that's a picture we're taking here from the roof through a very powerful telescope, and we're using a very, very dark filter to shoot through. It's called an Inconel filter. Which is a live picture.
Which is a reminder for all of you, no one, please don't look directly at the sun. To do so is just asking for permanent damage to your eyesight. Now, if we can, let's, Ben, show us what we should look for when the moon completely covers, or covers all but 0.3% of the sun at 12:23 Eastern Daylight Time this afternoon. You've got a couple of discs here to show us.
Of course, we've all seen all seen how the moon was gradually encroaching on the sun, and we're about here now, at this point. Now, if and when we reach the moment of totality, then the first thing that will happen to look for is that the sun will gradually set behind the mountains of the moon. And at the other side here, the moon will gradually expose the sun as we have passed it. So there will be both ends.
All right,
During the moment of totality, of course, we'll have the annulus, which is why this is called an annular eclipse. We'll have the ring around the sun, which in itself is dazzlingly bright. So from here to here takes 9 seconds.
All right, and we've got a picture. This was of the last annular eclipse we had in the United States in 1930, and I understand that this one might be quite similar. You can see the broken beads around the ring of the sun around the moon, and those are called Baily's beads.
They're named after the man who first observed this phenomenon. Now we're getting very close. It's a tremendously exciting day because we are fortunate in the weather here. I think the only place where we have such exceptional weather.
What makes this so exciting for amateur astronomers like you to see the moon as it approaches full totality and covering the sun?
Well, if you went, as I have done many times now, on an eclipse expedition, you'd hear people screaming when the moon actually hides the sun. It is a breathtaking moment because it is one of nature's most remarkable spectacles.
Now, we understand that total annularity, the path of total annularity, actually only takes about 40 minutes to run across the United States from just north of New Orleans through Montgomery, Georgia, and then on through here, Atlanta, and then through Petersburg, Virginia, just south of Richmond, and on out to the Delmarva Peninsula. That's moving, if my math is correct, at a rate of about 2,000 miles per hour.
2,000 miles an hour. In fact, the sun, the eclipse, could have been studied from the Pacific Ocean as early as sunrise and can be studied near Marrakesh and Casablanca in North Africa near sunset. So the event stretches from sunrise to sunset. Only the sun and the shadow race across us at noon.
And we here in Atlanta, of course, are directly under the path of total annularity. So this is really, you're seeing the best possible picture of any place in the world of this once in the last in this century of a total annular eclipse.
With the fine electronic equipment that you have ready to plug in here.
You know, maybe we could turn our camera down and we could show our viewers, if we could pan to the telescope arrangement we have on the roof of the building here. This began at 11 o'clock this morning, where the moon first took its bite, its crescent bite out of the sun.
Professionals call that first contact.
First contact. And what are we approaching? Second contact, which will be when the moon touches the other side?
When the moon actually starts to cover the sun. And then third contact is 8 or 9 seconds later when the moon moves off the sun. And then fourth contact is about 2 o'clock when the moon is totally off the sun. These terms, contact, are very misleading, but that's how science refers to them. The telescope, by the way, that is recording this is a Celestron 11, and this is an 11-inch diameter telescope. It is polar aligned. That means it is turning with our Earth, because our Earth is constantly turning, and we could not get this image so still if the instrument was not actually turning gradually one revolution in 24 hours.
Sorry to interrupt, gentlemen. We're going to have to take a break here just for a couple of seconds. And as we
occurs when the light from the sun passes through the moons and valleys and rills of the moon. And so basically what you're seeing is simply the sun from behind passing past the moon, and it's going through the lunar topology. And it's an interesting way of studying actually the surface of the moon.
This day is important not only to amateur stargazers, but especially to professionals, to physicists like yourself. What is it that an eclipse tells you?
Well, if it were a total eclipse, in fact, you could learn a bit more than you could through this annular one. If it were a total eclipse, and in Atlanta it's getting very close to being a total eclipse, then for a few moments you would be able to see the outer atmosphere of the sun called the corona. It's there all the time, of course. In fact, it's quite bright, but it is so dim compared with the solar disk that normally we can't see it. It's quite important for us to understand that outer atmosphere, the corona, because it affects the Earth. In fact, we are even in the very outer reaches of it ourselves. But even in an annular eclipse such as this, there's much to be learned. One thing is to measure the precise diameter of the sun as carefully as we can. We thought we knew the internal processes of the sun fairly well. The sun is a large nuclear furnace, converting some several hundred million tons of hydrogen into helium every second. It's been raging that way for about 4.6 billion years. In fact, a hydrogen bomb here on Earth is but a miniature replica of what the sun does all the time. Then about 10 to 12 years ago, we got some troubling data. They indicated that the sun may in fact not be the same size all the time. It may be shrinking, and then it may be expanding. If those data in fact were correct, then they would make suspect some of our theories, some of our understandings of the solar interior. If we are wrong on that, then we would also be wrong in our understanding of other stars and even of our nuclear processes here on Earth. In the last few years, the most recent data have reconfirmed what we used to think. So today's information will be quite important to tell us if we really do understand the nuclear processes in the interior of the sun. In addition to that, Einstein postulated his famous theory of general relativity. And one of the ways you test that is during an eclipse. The idea is very complex, but in essence what it amounts to is that he said that matter, gravity, a sun for example, will bend light. If a star is on the other side of the sun, a ray of light would normally pass directly to the Earth in a straight line. But when the sun gets very close to being in between the two of us, it will bend the ray of light. You can check for that degree of bending. That was first done in 1919, and lo and behold, what was observed was almost precisely what Einstein had predicted. The difficulty is that the angle is so tiny that the glare is so great, it's easy to make an error. In fact, the size of the angle is about the size that a dime would obtend at a distance of 1.5 miles. So one of the things to check today is whether there is that bending of starlight.
Dr. Berenson, does the eclipse of the sun, the annular eclipse that we're seeing today, casting all the old-time mythology and superstition aside, have any impact or effect on life on Earth?
Well, it certainly will have a minor impact on animal life. In fact, people along the path of annualism might check for this. It's quite intriguing, particularly with insects. Insects and other small animals can be misled into thinking that it's not only nighttime, but in fact it may be the onset of winter. Temperature will suddenly plummet, and something instinctive in them tells them that they should go into their normal autonomal type of behavior. And this is something that botanists and biologists have been studying in the last few decades.
Dr. Berenson, a few moments ago you pointed out that in the event of a total eclipse, we are able to observe, or scientists are able to observe the sun's corona, the outer atmosphere of the sun. Why is it important to look at that? What does that do that affects life here on Earth?
Well, the sun is, after all, our star. It is what makes all life on Earth possible. Planet Earth is simply piece of debris number 3 around the nearest star, which we call the sun. Our dependence upon the sun is absolute, it's total. It makes life here in all forms possible in terms of our heat, our radiation, our crop growth. The outer atmosphere of the sun extends for literally millions, even tens of millions of miles. We here on Earth are in the very far fringes of that atmosphere. When there are solar storms on the surface of the sun, they ultimately move up through the solar corona. They emit radio waves, and ultimately that affects us here on Earth. For example, the northern lights are caused by storms in the sun. Radio static and even interference on radio and television is caused by storms in the sun. Even, in fact, the safety of astronauts floating out in space around spacecraft or perhaps walking on the lunar surface could be affected by storms in the sun. So it is quite important for us to understand solar activity, whether at the surface or up in the corona.
Dr. Berenson, even after all the cautions, the warnings that have been delivered by people in your scientific community and people in the media over the past week or so about looking directly at the eclipse, we are seeing people walking around not just with the little pinholes in cardboards, but also with pieces of mylar, pieces of heavy film, and special lenses. Can you comment on that for us a little bit? Are there other safe ways to look directly at the eclipse?
There are, but very few laymen actually use them. You can use a piece of welder's glass of number 14 density, but how many people walk around with that in their pocket? That's what a welder would use to look at a very bright arc lamp. The usual layman's techniques of crossing two polarized filters or using a smoked piece of glass or an exposed color transparency that could be seen from the United States. There were afterwards about 140 reported cases of permanent eye damage in the United States, including blindness. It is no joke. People do not realize the intensity of the solar rays. They do not realize that their normal physical defense mechanisms weaken during the time of a solar eclipse because it is not so bright as usual. You don't blink as often as usual, but the heat is still there and it's simply burning a hole through the retina. The brightest thing to do is to watch it on television. The next best thing is to make a pinhole camera.
Some of the amateur eclipse watchers who travel throughout the world viewing eclipses, total and annular, say that it helps make them feel that they know where their place is in the universe in relation to the heavens and stars. Is that what it does for you?
I think it does. Let us realize that we're in a cosmos that's 18 billion years old, on a planet that is 4.6 billion years old, with human-like life that's a few million years old, with civilization a few thousand years old, with technology only a few tens of years old. Television, in fact, has been around less than my lifetime. There are moments, such as an eclipse, which remind us that we are a part of the cosmos. The iron in my microphone, in your body and in mine, was once brewed in the interior of a star that then died, blew it into space, it commingled with the original stuff of the universe, and ultimately made our planet, our atmosphere, and even our life. We need to be reminded from time to time that while war and peace and the national economy and paying for our own home mortgage is all important, and it's what consumes most of our thinking, we should pause, we should realize that in fact we're one with the cosmos.
Thank you, Dr. David Berenson, American University president, astronomer, and physicist, for joining us today on Take Two. Let's go back to the roof here at CNN now in Atlanta. Among those on the roof with our correspondent Charles Crawford is author and amateur astronomer Ben Mayer. Mr. Mayer, let's turn to you briefly. As we sit here and watch our live picture of the sun from what you have on the roof, I feel I can almost see it's David Wingert, who is a Georgia State University astronomer who's with us on the roof right now. I was saying I feel I can almost see the moon move across the path. It's going that fast.
You can indeed, Bob. In fact, we notice a perceptible darkening of the area around us. We also notice that the temperature is dropping. We understand the temperature dropped, what, up to perhaps 10 degrees?
Well, it's hard to say since it was already cold this morning for us here in Atlanta. But we're certainly feeling a temperature drop. People on the roof are beginning to put on a sweater or two.
Let's take another look at our live camera shot on the sun at this point, because the sun is now, what would you say, about 8/10 covered?
We've only got about 10 minutes or so left until the annular ring should appear, so the motion will be quite rapid from this point on.
Now, we should mention that we are videotaping this entire eclipse, and we'll make that tape available to the U.S. Naval Observatory at some later point. What will the Naval Observatory or astronomers, what might they be able to tell by looking at a tape of an eclipse like this?
Well, that tape, together with synchronized time signals, will really let us define the geometry of the moon and the sun, exactly where those objects are at this time. Especially we're interested in the angular size of the sun. Just how large is the sun? It turns out to be a very difficult thing to measure, and an eclipse is one opportunity to do that.
Now, what will it be able to perhaps tell us about the orbit of the moon around the Earth? Will we have a better understanding of the mechanics of that orbit?
Well, that's right. The orbit of the moon is really very complicated because it's influenced not only by the Earth's gravity, but by the sun's gravity, and to some extent the other planets pull on the moon. So following that moon to an accuracy of a few inches is a difficult job, and the eclipse timings will help.
As we get that totality of the annular eclipse, which will cover, I understand, 99.7% of the sun, describe what we may see. What should we look for on these, the phenomenon called Baily's beads?
Well, as the moon moves across, it's moving from west to east across the face of the sun. And at that leading edge, as the last sunlight is reduced, we may see only some of it shining through mountains on the moon. And then appearing at the other edge of the moon, we'll see sunlight peeking through those lunar valleys. Just exactly how much we'll have to wait and see, because it's so close to being the same size as the sun's disk.
We do have a photograph of an earlier annular eclipse. In fact, I think it was the last one in 1930. And perhaps at some point we might show our viewers that'll give them some idea what they might expect to see. Again, though, we must caution people, don't under any circumstances look directly at the sun. Even with that small, thin ring around the moon, it can cause and will cause permanent damage to your eyesight.
Dr. Wingert, by studying solar eclipses, can we glean any information which will help us in the space program?
I don't think that this particular solar eclipse is going to be especially valuable to the space program. We're able to produce artificial eclipses from satellites right now by having a disk over the brightest surface of the sun so that the corona will be visible.
I'd like to go back briefly to Dr. Berenson in Washington, D.C. in our bureau there. Dr. Berenson, we're approaching totality now. It is just about 5 minutes away, if the schedule is right that we've been given. Can you tell us why we're not seeing Baily's beads now? Why do we have to wait until totality?
Well, the solar photosphere, which is that arc that you're seeing, is still so bright that it simply masks anything else behind it. People simply do not understand how bright the solar surface is. It is brighter than any other thing that we will normally see in an entire lifetime. So you have to block out at least 99%, probably 99.5% of the solar surface before at last you'll begin to see those diamond ring effect around the edge.
Do you learn anything about the moon from all this?
Indeed you do, and prior to our lunar explorations, where we could actually send men to the moon and let them roam around in vehicles, it was one of the principal ways that we were able to study the lunar surface. Incidentally, you might notice that the surface of the shadow that's moving across the face of the sun is very clearly circular. This was something that was noted by the ancients, it was noted by the Greeks, and it confirmed to them that the moon is round, that the sun is round, and conversely, when the Earth's shadow falls on the moon during a lunar eclipse, the shadow is also round. So despite what you were told in school years ago, literally thousands of years prior to Columbus, it was well known to most scientists and intellectuals that the Earth was round and probably spherical.
Let's go back to Charles Crawford and Dr. David Wingert up on the roof. Is it getting darker up there, gentlemen?
It is indeed. I guess we're only about 7 minutes now away from the moon completely covering as much of the sun as it will. And you know, I have the feeling I'm looking through a pair of very, very dark sunglasses right now.
It's unusual because all around us there are no clouds. There is no reason for it to be getting darker, and yet we see slowly everything around us just sort of fading away.
The sky above us is getting considerably bluer. You can see the skyline of Atlanta behind us, and it is much darker blue than it was. But as you point out, we don't have a cloud in the sky, and it is a very, very strange feeling. Again, if we can go back to a live picture of the sun being covered by the moon, or the invisible dragon, as the Chinese would have it, devouring the moon. There's some absolutely incredible stories in mythology and history of of eclipses. One ancient one in China was that an invisible dragon came and devoured the moon, and the two astronomers who were supposed to be keeping guard were derelict in their duty, and they were beheaded for their efforts.
Well, that's right. In fact, we were very careful with our predictions today to keep them to astronomical predictions and not weather predictions.
About 9/10 now of the eclipse is completed. We're only 5 minutes, about 5 minutes away from when we hope we'll see this phenomenon known as Baily's beads, or the diamond effect.
Chuck Crawford?
Yes.
When we do look at you live on the roof there, you have television lights, electric lights on you, don't you?
Yes, we do, yes.
All right, we're seeing reflections of those on your foreheads, and that's giving us a slightly distorted picture of how bright or dark it is out there. We'll try to get, I think, a little later a picture that doesn't show those lights.
Perhaps we can have the lights turned off at some point, and you can see with just the... this is the parking lot below us off the roof that you're looking at. We don't have any particular animal life to show you, but it's a well-known and documented fact that as the eclipse does approach totality, birds go to roost in the nest. What else happens?
Well, the cows come into the barn to be milked, and it's been not unusual to observe some peculiar human behavior at the same time. We ought to know what's happening with the eclipse around us, but it's still an occasion for a good deal of unusual behavior on everyone's part, I think. You only have to look at us up here on the roof.
All right, we're about 3.5 minutes now. We've turned We've turned the lights off, so perhaps that gives you some sense now of the darkening skies around us here in Atlanta. We're right under the direct path of the annular total eclipse. In about just about 3 minutes from now, we should have the annular ring. Describe again what we'll be seeing when the moon completely covers the surface of the sun.
Well, quite without any mechanical interference or any sound or noise, the moon is going to just float in front of that sun's image. Just as we speak here, there is a sharp drop in temperature and a real feeling of darkness sweeping in from the southwest as the shadow comes up through Alabama, across Georgia, and on into South Carolina.
As we approach the moment of the best viewing and the appearance of Baily's beads, I want to quickly ask Dr. Berenson in Washington to reiterate for us briefly why we should not look at this with the naked eye. Dr. Berenson?
Are you there, Dr. Berenson?
Yes, indeed. The solar photosphere is so bright, so intense, that the heat rays from it will simply burn through the retina of your eye. It is extremely dangerous. People can be misled. They will not think that it's hurting their eye because they do not feel pain. Nonetheless, the radiation is eating away at the retina, and they will discover it a week, a month, or a year later. The best thing to do is to use a pinhole camera, or better yet, view it on television.
As you are doing, along with the rest of the country.
Are we beginning, gentlemen, anyone to see at the lower corner of the picture there, a Baily's bead?
I don't think so, but you are beginning to see a large part of the arc, and in probably 1 minute or so, the annular ring will go all the way around the entire thing, and I suspect then that you will see a burst of light someplace where the sun's rays are passing through one of the valleys or rills in the moon. It's a very thrilling thought to contemplate that you're seeing light coming from 93 million miles away, the sun, passing through a valley on the moon 250,000 miles away, and that's what will cause the Baily's bead.
Dr. Berenson, we know that Baily's beads are named after the 19th century English astronomer who first noted it. We also know that eclipses have been documented by history thousands of years before Christ. How do they explain the phenomenon before the 19th century?
And they weren't at all sure quite what it was, as a matter of fact, and back before the days of Galileo, it was considered sacrilegious to say that astronomical objects were not perfectly smooth. As a matter of fact, one of the reasons that Galileo got in trouble with the church was that he suggested that the moon was in fact rough and not absolutely smooth. They had a lot of trouble with that.
Chuck Crawford, on the roof?
Yes, and we should point out that Galileo, by the way, lost part of his vision by looking through his own invention, the telescope, at an eclipse. You can see how dark it's getting. In fact, there's some lights that have gone on, and the street lights are on now in downtown. Perhaps you can see them. If you'd move just that way, a little bit more, or come there we go. Well, we did there. You can see the streetlights on in downtown Atlanta.
There we go.
Let's go back, though, to our live picture as we are very, very close now to the total annularity. There you can see, those are Baily's
very
beads,
nice,
aren't they?
very nice Baily's beads on the lower left-hand side of the solar image, and the feeling of the shadow sweeping across now is very clear. And there is the annulus forming on the other side. The beautiful.
We can hear the cheers.
Beautiful.
Oops.
There you can see the break in the annulus now on the other side as the moon finishes its trip across the sun.
It didn't last long, though, did it?
Just a few seconds.
4 or 5 seconds. What a spectacular sight. And now, from this point, of course, the eclipse will continue, and the sun will begin to be revealed, or reveal itself, as the moon crosses the disk. How long will that take, Dr. Wynyard?
It will take about another hour and a half for the moon to completely uncover the sun. It's almost, right now we can feel the sunlight coming back.
Indeed.
The depth of the darkness here was like deep twilight, but it was unlike the twilight that you'd usually feel because the sun was not down on the horizon. It was straight overhead.
And I can assure you, because I am shivering, it is cold.
It's certainly cold for Atlanta in the month of May.
When will we get a chance to get another spectacular view of an eclipse like this in this country?
Well, for people who want to stay home, it's usually a long time. If you're willing to make reservations now for Hawaii, in 1991, we'll have a total solar eclipse where totality, the complete overlap of the moon on the sun, will last about 7 minutes compared to the few seconds that we enjoyed here today.
And as we pointed out, the streetlights of downtown Atlanta were, I assume they simply automatically go on by their electric eye-sensing devices.
Right.
But they'll probably go off very short. You can see the sunlight's coming back quite rapidly now. Of course, the shadow of that total annularity of the eclipse moves at a rate of, on the surface of the planet, at a rate of 2,000 miles an hour. And it will race now on north of Atlanta to a point just south of Richmond, Virginia, Petersburg, Virginia, and then from there on out over the Delmarva Peninsula, and then across the Atlantic Ocean to a point near Marrakesh, I believe, in North Africa, where the shadow disappears from the Earth just around dusk or sunset.
That's right,
Dr. Berenson in
African
Washington.
location.
Excuse me, Dr. Wingert. I was just going to ask Dr. Berenson about, he's been talking considerably, or you have, Doctor, about the brightness of the sun. How little of it, it strikes me, it takes to light up this Earth. The very little we see now is actually lighting up the Earth, isn't it?
That's exactly right. Sometimes we forget how much we are dependent upon the sun, how much we are a part of the total cosmos. And while we are awed by nature today, as we rightfully should be, let us also recognize that astronomers predicted this eclipse many decades ago. In fact, we've now projected the exact occurrences of eclipses right down to seconds of precision off into centuries into the future. We can know nature that precisely, and it never lets us down.
Certainly every telescope in the path of this annular eclipse has been focused on the sun, as have our cameras been focused during this time. Let's join Chuck Crawford up on the roof for a look at our telescope.
Okay, you're looking down from our position now up we're on the top of the elevator shaft, and this is just below us. That's our apparatus that we've been watching the total annular eclipse. We have a Celestron, 11-inch Celestron telescope on which we have mounted piggyback our own mini-cam with a 500 millimeter, well, it's about a 750 millimeter equivalent, I guess, lens that we took the picture of, and they're still having live pictures. As we said, we're videotaping this entire eclipse with a time signal, so we know exactly at what time the events occurred, and we'll make this available to the U.S. Naval Observatory in Washington for what we hope will be some scientific value.
I think these are going to be excellent observations, and other amateur astronomers all across the city have contributed to the timings and sightings, especially at the edges of the path. One of the biggest uncertainties was just how wide the path of annularity would be, and conditions were certainly good here today for determining that.
So maybe if we can go back now to a live picture of from our mini-cam atop of the telescope here, we can show you how the eclipse is progressing. We're now uncovering the face of the sun, and this will go on for, what, another hour and a half, right?
We expect the end of this final partial phase at about 2 p.m. here in Atlanta. But of course, as we stand here and say that the eclipse is ending, the shadow is sweeping on across Georgia and into the Carolinas. So for others, the peak of the eclipse is still to come.
And again, we can't caution you enough times, or strongly enough, don't look directly at the sun during any time, during this eclipse or any other time, because if you do, you will undoubtedly result in permanent damage to your eyesight.
Gentlemen, is the eclipse getting, if I can use the word, less total? Is it getting less total as it sweeps across to the east?
Yes, no question about it. It's basically in Atlanta at least now over, and it's going out of its totality. But as was just pointed out a moment ago, it now will be picking up in the Carolinas and then ultimately in Virginia and on across the country.
Well, to rephrase my question, to be sure we're on the same wavelength, are people in the Carolinas not getting as good a picture as we got?
No, the people in the Carolinas will get something close to as good. It turns out that Atlanta happens to be in a very propitious line of sight, and it's about a 99.7% totality there, which is, I think, larger than almost any other place along the path in the United States, at least in any major city. But they will be getting 99.2% or so, and that will be coming in just the next few minutes.
The voice you're hearing is that of Dr. Richard Berenson in our CNN bureau in Washington, D.C. Dr. Berenson is a physicist, astronomer, and the president of American University. Dr. Berenson, as a student of the history of science, If you could pick one scientific discovery that came about as a result of studying solar eclipses, what would it be? What is the most important critical finding that we've made?
Well, probably the most important scientific finding was the discovery of the intense heat of the solar corona. Prior to eclipse studies of that back some decades ago, we had assumed that the temperature in the outer atmosphere of the sun cooled off as a distance from the sun. We found that, in fact, it went just the opposite way. The surface of the sun is about 5,700 degrees Kelvin, whereas the atmosphere is several millions of degrees. That was quite a startling discovery. It told us something new about the entire structure of the sun and therefore of other stars. On the social science side, perhaps the most dramatic thing which ever came from a solar eclipse was 500 years ago during the 5-year-long war in Greece, when a solar eclipse occurred. It so startled the participants in the war that they took it as an omen of something, and they ended their war.
Charles Crawford?
Yes, we're told at another location we may have what's called the shadow band effect. Maybe you can explain that, and if we've got another camera somewhere that has that picture, we'll look at it.
Well, you can see some very peculiar shadows there that are cast when the sun's image is reduced to just a crescent. The leaves in the tree overhead are acting as little tiny pinhole cameras, and each crack between the leaves is casting a crescent image of the sun onto the ground.
Okay, they tell us they have some videotape of earlier when we did approach and have the total annular eclipse where we saw the Baily's Bees. Describe this for us, Dr. Winger.
The moon is moving across the sun from west to east at this very majestic and yet rapid pace. And you can see the glimmer of sunlight around the edge as the annulus forms. It was, in fact, a broken annular eclipse where the annulus was always broken on one side or the other by lunar mountains projecting into the sunlight.
Spectacular sight. So if we go back to our live camera at the present time, we can show you that how the eclipse is progressing and ending now. It's leaving the Atlanta area, as we said, racing northeastward toward Virginia and then out over the Delmarva Peninsula and out into the Atlantic. The eclipse will the sun will be completely revealed again when here in Atlanta?
At about 2 o'clock. It takes just about the same amount of time to uncover the sun as it took to cover it. So we had the eclipse here beginning just before 11, which is what an astronomer would call first contact, and last contact is expected about 2.
So we've had first contact, second contact, and third contact. We're waiting for the last one. Right?
That's right. And of course those contact terms are misleading because the moon is not in fact in contact with the sun. It's simply an overlap of their images.
When's the next time we might see an eclipse here?
Well, partial eclipses are not especially rare. Some sort of an eclipse occurs somewhere on the globe every 6 months. You have to be willing to travel in order to see them. So I wouldn't be surprised if several partial eclipses would be visible in Atlanta in the next 10 to 20 years. But for a good total eclipse of the sun, we'll be waiting, I think, until about the year 2017.
I'll be here with you.
Yeah, I plan to be.
All right.
Yeah.
Back to you, Ellen and Bob.
Thanks, Chuck. We'll all be here waiting for it. And we want to thank all of you who
Around the edge of the star.